Hi, I'm Eric Paulos. I'm an associate professor here in electrical engineering and computer science at UC Berkeley. I'm also on the faculty of the Berkeley Center for New Media, and I'm the faculty director of the exciting new MDes, the Master of Design program here at UC Berkeley. I want to take you on a tour of some of my favorite creative spaces on campus. Come on. I want to take you into Jacobs Hall. And this is one of the newest kind of maker spaces and educational buildings on campus. It's a place for prototyping, inventing, innovation, all kinds of things. I think you'll get the idea if we walk through. The building was designed to bring together sort of art and innovation. So these ideas of the sort of engineering and the humanities. And you'll see that spirit throughout the building. One of the things is this has one of the most active maker spaces on campus. And it is a 24,000 square foot building. Students can come in and they access the space through a maker pass system, which is very much like a library card for making, and allows students to come in and start using these facilities. One of the things you'll see is a lot of interesting tools and materials, but I really get excited about the people here. This is Joey Gobrath. He is the technical lab director here. Maybe he's the best person to tell us about the space, a little bit about himself. Joey?
Yeah, glad to. Really excited about the tour and the MDes program. So you're in the first floor of Makerspace, which is the biggest makerspace in the building, and this is kind of our catch-all. Not only is it a great place to come and meet with your teammates around a table or to do your big project layups, but we have some exciting technologies in here too. There's two main things that folks are interested in when they're coming here to make, and that is consumer 3D printing and laser cutting. So let's take a look at consumer 3D printing. We do have more high-end equipment upstairs, but the idea with this fleet of Ultimakers was that we wanted to increase the amount of throughput as much as possible to get as much people on machines and printing as we could. And so to that end, we only allow PLA to kind of streamline the material choices. We have a queuing system that allows users to upload their file, and then when their part is done, it's over on the done tray. And so that's a really great way to just get as many parts made as possible. But we also have Type A 3D printers, an Ultimaker, Lulzbots, and those are kind of more experimental machines. They're intended for people to come in with experimental filaments that they might want to try out, or processes that don't go well on the more broad machines like the Ultimaker fleet. And so the more functionality in this room around, we have a soft goods area, so people can do all sorts of sewing, whether that be on our industrial machines or on our consumer grade singers. We have a vacuum former for making really exciting parts. If you just have an object like a tape measure, you can easily make a mold of that object on this machine. We have a really great workshop that deals with people 3D printing an object and then doing this and then using that form to make custom chocolates. So a really fun application and just really exciting ways to get from 2D to 3D as quick as possible. Some other processes are our vinyl cutter, which handles heat press material too, so we can do one-off t-shirts or hoodies, things like that. So it's a really great attraction for teams that want to come in and do that kind of thing, and then we can kind of fool them into making 3D design. So some basic electronics, hand tools too, like soldering irons and thin gauge wire are available in this general makerspace, although we have a more high-end electronics upstairs for diagnostic tools, micro soldering, desoldering, those kind of things. But the basics take care of a lot of it. So if you're just using microprocessors or small electronics, you can get a lot of that done here. We'll also see on the other side that we have a great store, virtual store, that allows users to make purchases of microcontrollers or Arduinos or motors, or things like plywood for the lasers. And they can actually pick that material up from us, and then we bill them at the end of the semester in one big bill. So we try to cut the corners for the students as much as possible and make it so that they can do what they need to do here and not have to leave campus if they don't have to.
Great.
So all sorts of 3D printers, hand tools are accessible and not stored away in drawers where people can't see them or know what they are. And so that's all here too. We have a couple of design kiosks in the space that are loaded up with the software that our users are using in the space. So if they don't have it on their laptop or they don't have their laptop with them, they can design on the design kiosk and easily offload to the machines in the space. And so getting into our 3D printer, our laser cutter suites, we have 3 of them in there. Material available as scrap for free or in our store, as I mentioned. Getting into the dirtier sides of the first floor makerspace, we have our larger laser cutter at 2x4, and that's great for metal. That's great for wood or plastic. And we're starting to get into our CNC equipment too. So we have a full-scale shop bot up here, so it can handle 4x8 sheet goods. We sell sheet goods to the users too. It's also been used a lot for foam cutting to do pattern layup, or if you're doing layup of carbon fiber, you can cut your forms on this. So we'll see a lot of teams and clubs come in to use it for those kind of things. CAD CAM is really big here, and things like the ShopBot are an intro into that. Another one is the other mills, which are circuit board CNC machines, and those are kind of the onboarding to CNC that you'll see more of downstairs. And so in this messy side over here, we also have a woodworking suite, so table saw, bandsaw, sanders, drill press, things like that for breaking down material or doing some quick mock-ups. It's really handy to have that stuff accessible up here. And we also have some injection molding technology, and our actual practical store is here, so you're just picking up materials. One of the coolest pieces of technology that we're really excited about getting this last year has been the metal laser cutter. And so this is a really fantastic graduation from our normal universal lasers, where students are learning how to go from Illustrator, a very simple Illustrator or a DXF out of Fusion 360 onto those lasers. That same process you can use to create things not out of plywood or acrylic, but metal. And that allows for steel, mild steel, stainless steel, copper, and aluminum, a thin gauge, can all be very easily cut on this machine, and that introduces some of those properties. This machine actually even has a trunnion on it, and a trunnion is a way to actually hold the material and turn it, so that not only can it do sheet goods that you would normally see, but it can also do tube stock. So although this is kind of an architectural approach to that technology, you could very easily imagine taking two pieces of round tube and coping them on this machine in such a way that they fit together at an angle, which is usually a very technical, hard process to do. And here it can be done simply by going through a SolidWorks plugin. So we're really excited about introducing those same easy access technologies to materials like metal, which have durability and bendability, and things that could be more difficult to obtain or to take more hand touch to do. We've given students access to those things here.
And how do students get access to these materials? Like, how do you actually locate them, or is that something that's readily available?
It should be readily available. We've kind of tried to do the lowest hanging fruit and put it on a Shopify store that we have. As soon as you get your Maker Pass, you'll get invited to that store, and you can browse those items there. Once you make a purchase on that store, that e-store, you simply just go to one of our staff. They will look up your purchase and hand you the materials, and you'll be billed at the end of the semester. So we try to make it as easy as possible.
I love it. Okay, that was really inspirational. I can't wait to sort of spend more time down here. Thank you, great. Joey. That was a great sort of tour of just all the great things you can get involved with here. So we're going to move on. Thank you. So as you saw, there's just an amazing suite of tools and technologies. The idea is that this works very much like a menu. So you come in, as Joey was mentioning, maybe you start off working with hand tools or laser cutters or 3D printers. And as you move on, you take sort of simple online courses, get some training, and then you're able to use the whole suite of different facilities here at Jacobs Hall. The next place we're going to move into is some of the studio for instruction. So these are design studios where courses are held. So these are rooms that allow for sort of flexible teaching, different kinds of layout. They're a place to actually get dirty, work with different materials. Inside of each classroom, there are cabinets filled with prototyping material, things to help with electronics. And mainly, the space is where you can be creative. The courses that are taught in here, we have about 24 courses per semester. We'll go over the next one here. And the classes that are held in here are around 24 courses, as I said. They span a range of engineering disciplines, as well as theater, dance, performance studies, art practice, Center for New Media. We also have more advanced electronic prototyping, as Joey mentioned, where you can actually do a little bit more work in terms of smaller components and debugging. So there's a little bit more higher end digital debugging and test circuitry available. We're going to head up to the third floor. As I mentioned, there are also a lot of activity at night in the building. So not just the courses, but we also host a number of student clubs and also what we call DCALs. This is a Democratic Education at Cal. These are courses run by students, and they span a lot of different technical sort of skill sets that you might want to pick up. And so if you're here at night, the whole building takes on a different vibe. We're sort of sneaking in before the energy picks up today. This is the third floor. This obviously affords very large gatherings. So in here we can host larger courses, breakout events, workshops. We also host several speaker series. Currently, Design Conversations and Design Pioneers are two of them. We also have a Field Notes series where we bring in experts from the outside to inspire and learn from. So we're going to head into the advanced prototyping. So as you saw downstairs, there's lots of 3D printing available, but sometimes you want to work with different materials. You want to do things that actually involve microfluidics, or you need to work with nylon. And this is where you need to go. And this is really where a much more advanced prototyping facility is available. There's always the kind of most cutting edge different technologies here. This is Chris Barcel. He's one of the design specialists here. Chris, maybe tell us a little about the facilities here.
Sure, yeah. This is the Advanced Prototyping Lab. And we've got a variety of different kind of 3D printers, plastic printers primarily, kind that print similar but a little bit stronger materials than downstairs, filament printers that print ABS or polycarbonate. We also recently just got a printer that'll print nylon with carbon fiber, solid strand carbon fiber in it. Some samples of that around here somewhere, but multi-material printing that'll print different colored materials, not necessarily always the strongest material, but good representational models. And SLA printing with the Form 3 that could print, some strong and high-resolution single material prints. So you can print enclosures, some mechanical parts. Microfluidics has seen some success with a high resolution on that. And that's kind of generally what's going on in here.
So great. And also, it's not just obviously, again, the facilities, but people like Chris and others that have the design expertise to really talk you through and walk you through. Some of these are a little bit more exotic machines. They require a little bit of extra prep for some of your files. But people are here to kind of guide you and help you through that process. And mainly, you also take those designs that maybe you did in cardboard, maybe you did them in, PLA, and now you're able to actually build them with some structural integrity or some specific mechanical property. So we're going to head all the way down now to the basement. Again, I'll tell you a little bit more about the building. As I said, it is open, and it's also not just the design specialists, but there's also a suite of student supervisors that provide access outside of the main hours so that people can come in. They have their own skill set that they lend to the program. And there's a way to actually participate in that particular program. As I said, the kinds of classes that are taught here span many different disciplines, and you'll find classmates from, of course, places like engineering, electrical engineering, computer science, mechanical engineering, but you're also going to find students from English and rhetoric, architecture, theater, dance, performance studies, and so on. It's really a wealth of creativity, and the barrier to kind of starting to think and make through physical designs is really amazing. We're going to walk over to the metal shop. You saw a little bit from the fab light of working with metal, but there's actually a full shop that's available here at Jacobs Hall to work with metal. So again, the same system. As you gain your skills, you'll kind of learn more, and you'll suddenly be able to actually work with kind of metals and other materials. Again, here's Gary, one of our design specialists, why don't you show us around the shop and tell us a little bit about yourself, Gary?
Sure. I'm Gary, one of the design specialists, as Eric just said. But I've been building BattleBots for years, and so I've learned a lot about working with metal. So you can do that here in our metal shop. Probably the most popular tool we have is our water jet cutter, because you can cut pretty much anything in this machine. So you can cut any kind of metal, harder materials like ceramics, brittle materials like glass. You can also cut plastic in it. Unfortunately, you can only cut two-dimensional shapes. If you want to cut something in 3D, you'll have to use our Tormax 3-axis CNC milling machine. Once you get comfortable with that, you can move on up to this monster over here, which is our Haas mini mill, also a 3-axis CNC milling machine. And then we've got a bunch of classic metalworking tools, bandsaws, drill press, hydraulic press, belt sander. Yeah, so once you're done cutting all your parts apart or making your parts, you may want to attach them to one another. And for that, we have our Lincoln Electric TIG welder back here. So with the TIG welder, you can weld your parts together. TIG welding is very technique intensive, so if you want to learn how to TIG weld, prepare to spend a lot of time practicing. But once you're good at it, it's a great way to attach your metal parts back together.
Great, thanks, Gary. I'm always inspired by wandering through the building and finding all the different materials that you could sort of get your hands dirty with. But also, again, this idea that you don't have to take it all in at one time. You can start to learn and start to add on to your skill set and your design expertise as you kind of move forward. Now, one of the things that we're also interested in is thinking about the kinds of tools that might be in the future of these kinds of maker spaces. And we've been thinking a little bit about how to outfit not just 3D printers and laser cutters, but other kinds of technologies. So we're going to take a look at one of those that we're starting to prototype now, and that is actually using robots. We're thinking about how robots can be part of the making process, and they can also be another creative tool. I would think of it like a creative material you could work with. And here's Lucy and Ethel, and of course here's Cody, another one of our design specialists.
How's it going?
Great. Why don't you tell us a little about yourself and what we're looking at?
Yeah, so my name is Cody Glenn. I'm a design specialist here at the Jacobs Institute. Today we're looking at some robots here. These are Lucy and Ethel. They are 2 KUKA Agilis robots. They are insanely fast. They are extremely precise. They can go 1 meter per second and have repeatability down to 0.01 millimeters, which is insane. And the cool thing about these things is that they become whatever tool you put on it. So, for example, if you put a 3D print head on it, then it becomes a 3D printer. If you put a pen in it, like it is now, now becomes a multi-axis drawing tool. So, really, really cool tools. Very exciting to have here at the Jacobs Institute. So.
Oh my goodness, thank you, Cody. There's just too many sort of fun things to get into the sandbox and play with here. Yeah. I can't wait to see what happens with these robots. I like the naming too, thank you. All right, so you've got a sense of the building and the habitants, the kinds of space. We're gonna head on out, but I do wanna let you know that this is the kind of place that's always evolving. And when you come here, you're gonna find new kinds of technologies. You're also gonna find lots of different people intersecting the building. I already mentioned about the interdisciplinarity, but there's also a chance to have interactions across campus with making and prototyping, and some of the design from this building actually manifest themselves in other parts of campus. You'll get a chance to see that, hopefully. I encourage you to spend time in the building. It's a place that many people just stop by. I say, come for the laser cutter, but stay for the community. And that's what I see. A lot of people just come here to do something, then they get inspired to do more and be friends, and whole communities evolve. All right, au revoir, Jacobs Hall. We're gonna head out to our next adventure. So we've just walked over to Wurster Hall, the College of Environmental Design. This is another place where the MDes program is home. Let's go inside and meet Professor Kyle Steinfeld. Kyle.
Eric.
Great, good to see you.
Nice to see you.
Yeah, so great to be in Wurster Hall. Could you maybe show us around a little bit? Maybe get to see the College of Environmental Design Fabrication Shop?
Absolutely. These are the MDes students, right?
Yes, indeed.
Great, follow me.
Thanks.
So, welcome to Wurster Hall. This is the home of the College of Environmental Design. The building itself was actually was conceived of at the same time as the college, which was in the 1950s and early 1960s. At that time, the disciplines of architecture and landscape architecture and urban planning were thought of as separate disciplines. And William Wurster had a vision for the college that united them for the first time, and this building was a part of that vision. We're so excited for the MDes cohort to become a part of that synthetic vision for conceptualizing the built environment as a kind of totality that needs to be thought of at a variety of scales. We're walking now to the CED Fabrication Shop. This is a space that services all the departments that are housed here in CED. As we do so, we're passing through the material library, which is a subsidized store for student use that they use to build their architectural and in other kinds of models. So if you follow me through here, I think I see Samar. Hey, Samar. How you been?
Good. How are you?
Nice to see you. These are the MDes students.
Hi.
We were hoping to take them on a bit of a tour of the CED Fabrication Shop.
Great. Thanks for stopping by. Yeah, I can show you around real quick. So this is our fabrication shop. I'm Samar. I'm the director of these areas. Over here, you're going to see our metal area, which we have our welding equipment, machining equipment, and over here we have some of our woodworking equipment. These are some band saws and our sanding area. Walking into the space, you'll notice that we have really tall ceilings, really great natural light. We're really lucky to have a space like this for our shop. You'll notice that the majority of our shop is dedicated for woodworking. So here you have all of our workbenches that our students use to do their work. We have 3 table saws over here. These are all saw-stop saws, and we have them set up to do all sorts of different stuff. Definitely some of the more favorite tools for our students. Right near Kyle over here, we have our jointer, planer, and surface sander. These are the industrial woodworking equipment that we have, generally used for furniture making and solid wood work. We're always trying to improve this space, so we have projects here that we're working on. We're rebuilding all of our shop tables to try to make this space a little bit more flexible. We're supporting an exhibit for the architecture department that's going up in a couple of weeks. So that's what these things are. We have a self-serve tool wall here, just an array of hand tools that students are free to use and come and grab and go whenever they need when they are working in this space. Our staff is a full professional staff. That's, I believe, one of the highlights of our space and how we manage it. We want to make sure that we give our students the best support possible. But yeah, that's it. This is our shop.
Fantastic. Thanks so much.
Thanks so much, Kyle. Thanks for visiting.
I want to take you into the CITIRS Invention Lab. This was one of the very first makerspaces in the whole UC system, and it started in 2012, and it's one of my favorite places to go and be inspired. You come in and students access the lab through a Maker Pass system. This is like a library card for making, and it lets you access the facilities and the tools and the expertise. Oh, here's Chris Myers. He's the Senior Lab Manager of the CITIRS Invention Lab. Maybe he'll give us a tour.
Yes, come on in. Welcome. This is the CITIRS Invention Lab. We were one of the first makerspaces on campus, and I think the best. We have all these digital fabrication and hand tools for everyone's needs, student, faculty, staff, everyone. We welcome. This is our 3D printer rack, where you can just come in and grab your filament, load it up, and go. We don't even charge for the filament. And speaking of going, here we have our GoFab machines where you can actually check out a 3D printer. You can grab it, check it out, and go print wherever you want safely. Further on, we have more 3D printers. This is an ABS printer for all your ABS needs. Further on back, we have some SLA machines, laser-based resin printers. We can do really high resolution and pretty quickly too. So if you need to do a superhero chess set, you have it made here.
Chris, who are these people up here?
Those are a bunch of characters. No, this is our student staff, our super user staff. And this is a group of students who are highly trained and motivated. They keep this lab going after hours and on weekends. So we can offer a lot of different hours and fit the students' need, which is great. We have our first aid here, which is Band-Aids for all your needs, because we have all these amazing hand tools. So you could actually grab something off the printer or laser cutter and then continue modifying it to work. Come on back here. We have some great area to get messy. We have a vinyl cutter here for all your laptop sticker needs. This is very popular. It's very busy in the beginning of the semester usually. Back here we have a casting area for silicone molds and soft tooling. Casting in other flexible materials or urethanes, with vacuum tanks, pressure vessels to get very high quality casted parts from. We have a vacuum form, pretty nice automatic vacuum form machine, pretty automated for a lot of thermal forming and things of that nature. Over here we have our laser cutter stations. We have two pretty good laser cutters. They get a lot of use and fulfill a lot of needs. We have back here we have circuit board mills. We have an LPKF, which does basically industry standard type double layered boards. And we have a other mill for simpler things. And we like to think that you can come in here and breadboard and then CAD up your design and mill out your circuits and walk away with a completed. Oh, look here. Here's a student returning a GoFab printer. Hey, student. So, hey, printer. We have a reflow oven and microscope so you can do SMD work. Some really nice soldering stations. Where you can actually solder everything together, scopes, power supplies, all this electronic equipment. This is a pretty well outfitted electrical bench area. Moving on. We have a lot of cool projects going on. This is a really neat little robot that uses camera AI. It's going to be for a art and technology project for a museum exhibition. This is just a scale prototype to prototype the electronics and the programming. And the real one's going to be giant and yeah, really cool. We have a whiteboard, projector, everything. We do classes in here, a lot of workshops in here, a lot of school groups, teams meet in here, like FemTech, Girls in Engineering, Enable Tech, the Rocket Club, and a lot of different groups, engineering groups and non-engineering groups come in here and use our space.
This has been great. I love visiting the Invention Lab. It's one of my favorite places on campus. It's full of not only exciting materials and tools, but people. Chris himself is a little modest. He comes from a background in Art Center College of Design. He also did a lot with toy design. He teaches many of the design innovation courses. I always come in here to be inspired by what's just happening. I say, come for the laser cutter, stay for the community. It's a really great place to really sit yourself down and get your hands dirty and really explore some really cool materials. I know it's going to pick up and get really busy in here, so we're going to move on. I think I'll take one of these GoFabs to go on my own adventure.